Hello everyone, this is Half-Life 390 here again with another Redstone video, as you can probably tell. So this is my plot on the ORE server, the Open Redstone Engineers. Awesome server for doing Redstone. I strongly recommend it if any of you are serious Redstoners out there. Just another update video on my CPU slash computer, because I've done a lot more to it and it looks pretty epic now. So, as it says on the sign, above mega computer under construction. Dun dun. Dun dun. Yes. Look at it. It's even making me lag like loads. Right, let me go up there. And I'll show you what I've done since the last video. Now, in the last video, I showed you and explained to you more about the CPU. I found the proper word for it now, the proper name. It's von Neumann. That is the name of the architecture that I'm using, von Neumann architecture, which basically means that, most CPUs made in Minecraft are what we call Harvard architecture. But von Neumann architecture is where you basically have one massive bus that goes around the whole CPU, and only one value can be on that bus at any one time. But then that bus does connect to every single component, so you can quickly move data around. Now, it's not as fast as Harvard, because Harvard has separate buses for different things, but I like it and think it's better, and modern CPUs use that, so why not? And it was also in the book I read on how to actually make a CPU, so there we go. So as I showed you last video, we have the LU here, fully done, properly, decoder, registers, everything. Well, the LU doesn't actually have its own registers. It does have a few that function within it, though, as in this one here. This is the temporary register, for temporarily storing the B input, because you need to do that, because you have the A input on the bus and the B input coming from there. You also have the accumulator here, which is obviously the register which saves the output of the LU before going on to the bus. Now, that's all what we covered last video. But the main development, first of all, is these registers. They're 16 in total, 16 8-bit registers, only for storing values, not instructions. There is no space because they're only 8-bit and instructions are 20-bit. Right, now in the last video I did have these, but now they're properly wired up. They have all the read and write wires here. That's what all this is. Read and write wires, that's all it is. Loads of instant repeaters, because I really wanted to, now that I found instant repeaters for the bus, I wanted to make up the speed elsewhere as well. So that's what I've got here. Yeah, so these read-write wires then go in to this big section here. And this section is the CU, the control unit. The control unit is the part that controls the CPU. So it's almost like a brain within a brain. This control unit controls all the registers, it controls the LU, it controls everything. I'm just turn my render distance down. Oh yeah, we're 1.7 now. How awesome. Yeah, so this control section controls the LU and the registers and things. Now this isn't done because this is extremely complicated to do. It's really annoying wiring. You have to do like wire acrobatics in order to get things going in the right way. So that's why I'm sort of procrastinating from doing this, and I've moved on to actually the RAM, which I'm not going to show in this video because that deserves its own video. So what we have first of all is this mossy cobblestone thing. This is called the stepper. This basically steps along almost like a program counter from one step to the next, and each step is access to every single different instruction that the CPU can do, basically, and AND gates used from the main decoder in the middle control which instruction you're doing, basically. Inside the control section you have all the sets and all the enables for every single register. So that's the save and the allow output, if you didn't know. So for all the general purpose registers, for the temporary register, accumulator, all of that. Don't want to make this video as long as last one, so I'm just going to quickly hurry up. You've also got decoders in here, all the stones, sort of like the CU part. The decoders for each of the selecting all the 16 different registers, for your A register, your B register, and your O register. Here we have the instruction register, and this stores the instruction, so the bus can be used whilst the instruction is still stored in here. Like I said, it's 20 bits long. Yeah, and this needs a hell loads of busing in order to be done. Loads. And very down here, you also have... Wait, there, that goes into the LU. There, that controls the LU decoder. Right, so that's pretty much all in the CU. I need to do a lot more to it, though. I've also quickly added, around here, just a section where I can directly input numbers onto the bus, because it gets a bit confusing when I'm entering instructions normally, because the way I've organised it is that it's an 8-bit bus, but for instructions there is a separate 8-bit bus, well, 10-bit bus almost, yeah, these two 10-bit buses, and it sort of goes like these ones, and it suddenly skips to up here, then it skips to down there, and then it skips to down here, and that got really confusing, so I just made a quick input area there. The final thing I've added is the instruction address register, and that's this over here. That's exactly the same as a standard general purpose register, but it's just been put over here, and this was one special function, which is store the address of the next, the RAM address of the next instruction. Yeah, so that's added, and the set and enables of those are obviously in the control section. Oh yeah, the final thing as well, the diamond is all the clock. So that's the clock there. It's going to be a lot smaller. That's just for debugging at the moment. Then we've got the edited clock signals, one for set, one for enable, and one for the stepper, and those go to the set and enables. And they probably go to other places as well, maybe. But there you go. That's starting on the RAM. I'm not going to show you that at the moment because that's absolutely awesome. But yeah, so that's all I've done so far. That's a massive chunk of the work done. I'm really happy with it. It's actually really fast, surprisingly. And it's very big, not surprisingly. I've got to do loads to the CU. I've also got to wire up a few things here and there, like the flags register. The outputs of those need to go in here. Stuff like that, really. And then I just need to add the memory address register over there, next to that. That will hook up to the RAM. And I need to make another bus here that connects up to the RAM. And I need to actually do the RAM, because I haven't done that yet. I've only done half of it. And then it will be done as a computer. I'm actually going to probably end up finishing it as a computer rather than a CPU, because I really want to get the RAM done, because it's getting annoying not knowing how I'm going to do it. So I just want to get it sorted, get it done, so I know what I'm doing for the RAM. Yeah, so that's pretty much it. Thanks for watching this video. There'll be more updates soon. Stick around, this is going to be awesome once it's done. Very laggy, very slow, but it will be awesome. Okay, see you next video.